students. Today our new concept in real numbers is represent terminating decimals on number line. Now we are going to take one from example. I am taking an example 2.776 is a terminating decimal. This terminating decimal represent on number line. Now I am taking a number line is in between 2.776 is in between 2 and 3. Now I am taking a number line from 2 to 3, 2, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9 and 3. The value 2.776 is in between 2 and 3 integers. Now the value is 2.776. It is in between 2.7 and 2.8. 2.7 and 2.8. Now I am going, you can take these two are the value 2.776 is in between these two. Now I am taking 2.7 and 2.71, 2.72, 2.73, 2.74, 2.75, 2.76, 2.77, 2.78, 2.79 and 2.8. Now I am taking this 2.7 and 8 number line extended. Now again the value is 2.776 is in between 2.77 and 2.78. Again closerly see. Now again you have to draw one more line. This is in between 2.77 and 2.78. Now I am taking from 2.77, 2.771, 2.772, 2.773, 2.774, 2.775, 2.776, 2.777, 2.778, 2.779, 2.78. The value is in between 2.77 to 2.7. Okay. The values are 2.77 to 2.78. 78 is nothing but 780 and 2.77 means 770 is in between these two, 2.771, 772, 773 and all. Now I want 2.776. Where is it? This is the 2.776. Now this value is the exact value of given problem. Like this you have to represent on number line terminating decimals. If it is one more number we have, if it is 5, you can continue like this. Now we are going one more problem, one more example, that is terminating, non-terminating, repeating decimal. Now I am going to non-terminating, repeating decimal, that is for example 3.58 bar. 3.58 bar is in between 3 and 4. It is in between 3 and 4. And also it is take up to 4 decimal places. 4 decimal places. Now I am taking like this. Number line is in between from 3 to 4. Take a number line. Start from 3 and 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9 and it is 4 or 4.0. Now the value up to 4 decimal places means 3.5888. The value is 3.5888. Once observe here, after decimal there is a 4 numbers. We want 4 decimal places. Now first one, this 3.58, where is it? 3.5. The value of 3.58 bar is in between 3.5 and 3.6. Now extend in between 3.5 and 3.6. Now I am taking 3.5, means 3.50, 3.51, 3.52, 3.53, 3.54, 3.55, 3.56, 3.57, 3.58, 3.59, 3.6 or 3.60. Now I want 3.588. 3.58 is in between 3.58 and 3.59. Now again do same process, continue the same process up to the 4 decimal places. Now in this case we got only 2 decimal places, we can do 2 more times. Now the first value is 3.58 or 580. Now next 3.581, 3.582, 3.583, 3.584, 3.585, 3.586, 3.587, 3.588, 3.589, 3.59. That means 590. The values in between 3.58 and 3.59 are these all values, and we want 3.5888. Now it is in between 3.588 and 3.589. We want one more decimal. Now draw one more line. It is start from the 3.588 and then 3.5881, 3.5882, 3.5883, 3.5884, 3.5885, 3.5886, 3.5887, 3.5888, 3.5889, 3.589. Now once observe, we want the value of 3.5888. 3.5888. This is the value. Now like this you have to represent non-terminating repeating decimal. Yes, now from using these 2 examples you have to complete exercise 1.3. Exercise 1. Yes, now representation of terminating and non-terminating repeating decimals are completed. Now new concept, that is operations of real numbers. Operations of real numbers, the first point, the sum, difference, coefficients and product, whatever it is, of irrational numbers. Any 2 irrational numbers, sum or difference or coefficient or product, need not be a irrational number. Once give one example and prove it. First I am taking example for the sum. I am taking 2 numbers, √2 and -√2. √2 and -√2, both are irrational numbers. Both are irrational numbers. Then by this concept, sum of these two numbers is also either rational or real, either rational or irrational. Once see here, sum of these two, sum root 2 plus of minus root 2. Root 2 plus into minus minus root 2. Root 2 minus root 2 we get 0. 0 is a rational number. Rational number. From this example we can say the sum of any two irrational numbers need not to be a irrational. That means may be rational or irrational. Now I am taking product, same numbers for the difference. Now I am taking one more example for the difference. Root 2 and root 2 are the irrational numbers. Then the difference of those two numbers, root 2 minus of root 2. Root 2 minus of root 2. Root 2 minus root 2 we get 0. 0 is a rational number. 0 is a rational number. By this example we can say any two rationals difference is also need not to be irrational. Need not to be irrational. Now once check for the product. Product of these two numbers, root 2 into root 2. Not only root 2, you have to take one more example, root 3 into root 3. Root 3 into root 3 whole square. Square and root will be cancelled. Now we get 3. What is the 3? Is a rational number. Is a rational. If you take this example, root 2 into root 2 whole square, the value of this one is 2. 2 is also rational. From this, the product of two irrational numbers need not to be irrational. Similarly, you can say the coefficient of two irrational numbers is also need not be a irrational number. Now we can go to the next concept, that is, if I am taking two numbers, one is a rational, other one is irrational. I am taking Q is a rational number and S is a irrational number, and apply the operations, fundamental operations, either addition or difference or product or coefficient, irrational or irrational. One is irrational and one more is rational, then those operations are like this. I am taking example 12 and explain this one. Product of rational and irrational. Product of rational and irrational is, by this it is irrational. Once observe, 5 into, what is the value of root 2? We know already, 1.414 and so on. Now if you product this value, 5 4s are 20, 5 1s are 5 plus 2, 7, 5 4s are 20, 5 1s are 5 plus 2, 7. That means the value is 7.070 and so on. That means this is non-terminating, non-repeating decimal. Non-terminating, non-repeating decimal is a irrational. That means QS is a irrational number. It is completed. Now I am taking this 5 by root 2. 5 by 1.414. It is approximately 3 point something. That means it is also non-terminating, non-repeating decimal. Non-terminating, non-repeating decimals are irrational numbers. Then 5 by root 2 is also irrational number. Now 21 plus root 3. 21 plus root 3. What is the value of root 3? 1.732 and so on. The approximate value of root 3 is 1.732 and so on. If you add this one, 22.732 and so on. 22.732 2.732 and so on. It is also non-terminating, non-repeating decimal. Non-terminating, non-repeating decimals are irrational numbers. Therefore, 21 plus root 3 is also irrational number. We are going to one more example, pi plus 3. What is the approximate value of pi? 3.14 and so on, plus 3. If you add this one, 6.14 and so on. Non-terminating, non-repeating decimal. It is also irrational. Now I am observing if it is minus difference. If it is minus, subtract 3 from this value. 3 minus 3 it is 0. That means 0.142 and so on. That means it is also non-terminating repeating decimal, non-terminating non-repeating decimal. It is also irrational number. Now we are going to the rationalizing factors. What is the rationalizing factor? If product of any two irrational numbers, I am taking root 2 into root 3. Product of any two irrational numbers, root 2 into root 3 is root 6, is also irrational. Root 6 is also irrational. Now I am taking root 6 into root 6 into 2 root 3. Root 6 into 2 root 3 is root 36. It is nothing but 6. That means it is a rational number. That means it is a rational number. Otherwise, you can take like this one more example. 2 root 3 into root 3. 2 root 3 into root 3. Now it is root 36. This is also 6, is also rational number. Is also rational number. By observation, root 2 into root 3, irrational, both are irrational numbers, we get irrational. And in this case also both are irrational numbers, we get a rational number. In this case also two different irrational numbers, product is also rational number. That means product of any two irrational numbers is a rational number, then each of one and each is root 3 is the rationalizing factor of 2 root 3 as well as 2 root 3 is the rationalizing factor of root 3. In this case also, root 6 is the rationalizing factor of 2 root 3. 2 root 3 is the rationalizing factor of root 6. When it is comes, the product of two irrational numbers is a rational, then only 1 and 1, root 6 is a rationalizing factor of 2 root 3 as well as 2 root 3 is the rationalizing factor of root 6. Now we can observe some more examples. Yes, page number 19, example 14. Once see that problem. Multiply 6 root 3 with 13 root 3. Multiply these two numbers. 16 3's root 3 into root 3. 6 into 13 into root 3 whole square. 6 into 13 into root 3 whole square. That means 6 into 13 into 3. Now product here, 6 3's are 18. 18 into 13. 4, 13 and 2. 234 is a rational number. In this case, we can say 6 root 3 is a rationalizing factor of 13 root 3 as well as 13 root 3 is a rationalizing factor of 6 root 3 also. Now, we have some properties. Already in our last class, we discussed that. That is root A into root B. Root A into root B is equal to root AB. Root A by root B is equal to root A by B. Root A plus root B whole square equal to A plus 2 root AB plus B and so on. So many, some more examples are there, some more properties. Using these properties, you can find those problems. You can find the values of some questions. Example 15. Once see the example 15. Example 15 is simplify the following expressions. 3 plus root 3 into 3 plus root 3 into 2 plus root 2. Example 15 in first one. 3 plus root 3 into 2 plus root 2. In this case, a plus root b into c plus root d formula. Now product like this. 3 2s 6. 3 into root 2, 3 root 2. Product first one into 2 and this. And again, root 3 into 2, 2 root 3 plus root 3 into root 2, root a into root b, root ab, root 6. This is the simplest form. Now in this case, rational, irrational, irrational and irrational. Now this total term is a irrational term. Now we are taking one more example. 2 plus root 3 into 2 minus root 3. 2 plus root 3 into 2 minus root 3. A plus root b into a minus root b. What is the formula? A square minus b. A square minus b. Using this formula, a plus root b into a minus root b. Using this formula, apply for this. A square 2 square minus b 3. 4 minus 3. The value is 1. Like this, using those properties, we have to complete example 15. Now we are going to example 16. Example 16. Once see the example 16 in page number 21. Rationalize the denominator 1 by 4 plus root 5. 1 by 4 plus root 5. Just rationalize this denominator. What is the rationalizing factor of 4 plus root 5? 4 plus root 5 rationalizing factor is 4 minus root 5. When you product these two numbers, we get a rational number. Then 1 by 4 plus root 5 multiply and divide with 4 minus root 5. Multiply and divide with the rationalizing factor. Then we get numerator is 4 minus root 5 by the denominator is a formula 4 square 16 minus 5. 4 minus root 5 by 16 minus 5 is 11. Once observe here. In problem 4 plus root 5, denominator 4 plus root 5 is a irrational. In the answer 11, the denominator having 11 is a rational number. Then it is the process to rationalize the denominator. Now one more problem, example 17. Example 17 and వచ్చిందా? Okay, now rationalizing factor of 1 by 7 plus 4 root 3. 1 by 7 plus 4 root 3. In this denominator is 7 plus 4 root 3. Rationalize this denominator. Now I am taking the rationalizing factor of this one is 7 plus 4 root 3 is 7 minus 4 root 3. Now product and divide. 1 by 7 plus 4 root 3 multiply and divide with 7 minus 4 root 3. 7 minus 4 root 3. And then the numerator is 7 minus 4 root 3 and the denominator is a square, that means 7 square minus 4 square into 3. Now 7 minus 4 root 3 by 7 square 49 minus 4 square 16, 3s are 48. Now it is 7 minus 4 root 3 by 1. Once observe here, the denominator is 1 is a rational number. Now rationalizing factor of 7 plus 4 root 3 is a 7 minus 4 root 3. 1 by 7 plus 4 root 3 can be written as 7 minus 4 root 3 by 1. Now once see the about this rationalizing factor. If the product of two irrational numbers is a rational number, then each of the two is the rationalizing factor of the other. Once observe again, if the product of two irrational numbers is a rational number, then each of the two is the rationalizing factor of the other. Rationalizing factor of a given rational number is not unique. For example, 7 root 3, if you take 7 root 3, root 3 is a rationalizing factor, and 2 root 3 is also rationalizing factor, 3 root 3, 4 root 3, 5 root 3, and so on. These all are rationalizing factors of 7 root 3. Rationalizing factors, these all are rationalizing factors of 7 root 3, but the simplest rationalizing factor is root 3. But the simplest rationalizing factor is root 3. Like this, you have to complete the exercise, and we are going to the laws of exponents. From 6th class onwards, we know the laws of exponents. A power m into a power n is equal to a power m plus n. అలాగే a power m by a power n is equal to a power m minus n. A power m whole power n is equal to a power m n, and a to the power of 0 is equal to 1, and 1 by a to the power of minus n is equal to a power n. These all are the properties of the exponents and powers. A power m into a power n equal to a power m plus n. A power m by a power n is equal to a power m minus n. A power m whole power n is equal to a power mn. A power 0 equal to 1. 1 by a to the power of minus n is equal to a to the power of n. For example, I am taking a power n. In this case, a is called the base. It is the exponential form. In this case, a is called the base and n is called the power or exponent. Power or exponent. Now we are going to the new concept, surd. Now the last concept of the real numbers is a surd. Now we know already exponents. Now we are going to the surd. If n is a positive integer and it is greater than 1, n is a positive integer and also greater than 1, and a is a positive rational number. N is a positive integer and greater than, must be greater than 1, and a is a positive rational number but not nth power of any rational number, then nth root a we read as a nth root a or a to the power of 1 by n. Nth root a or a to the power of 1 by n is called a surd of nth order. Nth root a is called a surd of nth order. In this nth root is called a radical sign. Nth root is called a radical sign. N is called the degree of the surd or degree of the radical. A is called the radical. This is about the surd. Using this surd, we can do the exercise 1.4. It is the new concept for the 9th class. Once see one problem example, problem number 9 in page number 25. Page number 25, problem number 9. It is very important. Simplify 4th root 81. Minus 8 into cube root of 343 plus 15 into 5th root of 32 plus root of 225. Now we are going to find root 81. I am doing prime factorizations of 81. 3 table 27 times, and again 3 table 9 times, 3 table 3 times. That means 3 to the power of 4. 4th root 81 means 4th root of 3 power 4 minus 8 into cube root of 343. Once check 7 table. 7 4 jar 28. 7 4 jar 28. That means 63. 7 9 jar 63. Again 7 table 7 times. 343 means it is 7 cube plus 15 into 5th root of, you can read as a 5th root of 32 can be written 2 to the power of 5. 2 to the power of 5 plus square root of 225 means 15 square. If it is 4th root, we can write in the 3 power 4. If it is cube root, write in power cube. 5th root, power 5. Square root, write in square. Now, 4th root and 4 will be cancelled, power 4 will be cancelled. Now it is simply 3 minus 8 into cube root and cube is cancelled, simply 7 plus 15. 5th root and 5 is cancelled, now the value is 2, and 15 root and square will be cancelled, just it is 50. Now simplify. 3 minus 8 7 jar 56 plus 15 2 jar 30 plus 15. Now add positive terms. 30, 45, 48. 48 subtract from 56. Now it is 8, but it is negative sign. Now the answer is minus 8. Minus 8. Simplify 4th root 81 minus 8 into cube root of 343 plus 15 into 5th root of 32 plus root of 225. The value is minus 8. Like this you have to complete exercise 1.4. Now we are completing the first topic, real numbers. Everyone should do each and every problem. If you have any doubt, please contact me. Thank you.